Good afternoon. Today we will be talking about non-parametric tests. Part 1 will be about Mann-Whitney test. This lecture is mainly from this source. These are the authors here, and also from your textbook, Statistical Methods for Food Science. What do we mean by non-parametric tests? Statistical tests fall into two types, either parametric or non-parametric. We use the parametric tests when our data follows a particular distribution, mainly normal distribution. However, if this condition is not met, we usually use the non-parametric test that based mainly on rank and sign rather than actual data. The non-parametric tests methods are used when our data is normal or is ordinal. Data does not seem to follow any particular shape or distribution, mainly normal. For instance, if we look for this data, we can see that the data are skewed here. It's not normally distributed. Also, we use the non-parametric tests when the assumptions underlying parametric test not met. What are the assumptions that are needed to conduct parametric tests? They are random independent samples, normally distributed data, no outliers, and homogeneity of variance. If these conditions or assumptions are not met, we then shift to the non-parametric tests. However, the parametric tests are more powerful, which means that they are more likely to detect differences that truly exist. Also, they less likely than non-parametric tests to make a type 2 error. Therefore, they are more powerful than non-parametric tests. To summarize, we work with dependent variable to analyze it actually. If the measurement of the variable is scale, then we use parametric tests if the distribution of the data are normal. However, we use non-parametric tests if the distribution was not normal. In case of categorical dependent variable, we have two cases, either ordinal, and then we use non-parametric tests, or nominal, we use the chi-square test. Do these look normally distributed? For instance, you can see that the first distribution is not normal. However, these two distributions are not normal. These distributions are normal, and this one is not normal. What can be done about non-normality? If the data are not normally distributed, there are two options: either to use non-parametric test, as we mentioned before, or transform the dependent variable. For instance, for positively skewed data, in this case, for instance, if the data are transformed to logarithmic value, then the distribution of the transformed data is approximately normal. For instance, if we want to compare the data, the histogram of two different data about the housework hours for both female and male, you can see that in case of the female, the data are all approximately normal. However, in the case of the male, the data is not normal. Then what can we do in this case when the data is skewed? So we cannot use the parametric test. We have to use non-parametric test in case of the male data. What are the non-parametric tests that are equivalent to parametric tests? For instance, when we want to compare two independent groups, we usually use the t-test in case of parametric test, or in case the conditions are met, like normal distribution. If the conditions or assumptions were not met, then we use the non-parametric test, Mann-Whitney test. For paired sample t-test, the alternative in the non-parametric test is the Wilcoxon signed rank test. For one-way ANOVA, the alternative is Kruskal-Wallis test, and for one-way repeated measure ANOVA, which is almost similar to the block design, we use the Friedman's ANOVA. What to check for normality? In case of the independent t-test, we need to test the dependent variable by group. We have to test the normality of the dependent variable for each group. If the distribution was not normal, we use the Mann-Whitney test. For pair test, we test the pair differences, the normality of the pair differences, and for the one-way ANOVA, we test the residual dependent variable. The residual are the differences between the observed and the expected value. Because one condition of the one-way ANOVA as a parametric test is that the error should be normally independent distributed, and the residual actually is a measure of the error of the experiment. For the repeated measures ANOVA, again we test the normality of the residuals. Now let's look for the first case. We want to use the Mann-Whitney test when we have two independent groups and the data are not normally distributed. Here we have a case, a search question: does drinking the legal limit of alcohol affect driving reaction times? Two groups of participants were given either alcoholic or non-alcoholic, so two independent groups, and the driving reaction times was tested. These are the data. Here are the data for each group in seconds. Actually, when we rank the data, is the scale data is ordered and ranked like this, and the analysis is carried out on, this is the group, the reaction time, and the rank. Okay, then the analysis will be done on the rank rather than the actual data. Let's go to the mini tab and see how to analyze such data. No. Here is our data again. We entered the data for both groups, independent groups, placebo and alcohol. And first of all, we need to test for the normality of each group. We go for immediately statistics, basic statistics, normality test. We enter variable 1, use this test. Okay, here is the distribution. The distribution is not normal, and the p-value for the test was less than 0.05, which means that the distribution is not normal, because when we test the normality, the null hypothesis is that the distribution is normal, and since the p-value is less than 0.05, we reject the null hypothesis and our distribution is not normal in this case. Okay, we don't need this. Now we go back to the data and test the other group for normality. Test the alcohol group. The same thing, the p-value is less than 0.05, so the distribution of each group were not normal. Now we go immediately, because we have two independent groups, we go to the Mann-Whitney test, statistics, non-parametrics, Mann-Whitney. Here we are. We enter our variables, first sample to second sample, and we go forward. Okay, so the test is for the rank, which means for the median, and we can see here that the null hypothesis that the two medians are equal, the alternative hypothesis two medians are not equal, and the test shows that the p-value was 0.009, which means highly significant, which means that there is a significant difference between the two groups in this example. Thank you.